I feel kind of daunted now. Because he said there already everything we have. So. But I think there's a major difference really here. The title is really in the title, VM infrastructure. We heard a bit of. I think is centralized computing, and it's a decentralized microscopy environment. And it's a university, and it's not organized at all. As you all know, universities are not organized. We are a cool facility, and that's where I'm coming from. So I realized over the year, life is not as Dean was telling us right now. Not for many research groups, and not for many researchers. So they still work similar to what I did 20 years ago. Kind of correlative studies of growth cones or whatever, cell motility, single images, single time-lapse movies. And now we heard, exactly right before we heard light sheet data, here is a mosquito larva, or we heard electron microscopy. 3D data, it will be large. And that actually has been the start when we thought about how can we help people analyzing data. Because the data is large, 1 terabyte. It's gigantic. You cannot transfer it to the server. You don't have a server, you don't have a workstation. That has been the initial start. And you will see in the end that actually I don't think that's really the problem. We operate 27 microscopy systems. Not research groups have their own. So it's relatively large. It's 19 light microscopes, everything basically. It's light scanners, it's high content screening, it's light shades. We have 2 cryo-electron microscopes. We have TEMs. We have scanning electron microscopes for 3D imaging, focused ion beam. So it's basically the whole flavor of microscopes. There are something like 500 users coming each year. There are 200 new users coming each year. And I have to say, we have one IT guy, one. Obviously, we have a scientific computing environment, S3IT, which is newly formed. But basically, most of the jobs you have to do with one guy. And there are a few scientists dealing with microscopes. Nowadays, we have 1.2 petabyte of storage service. In contrast to FMI and other research institutions, we are not responsible for storing data, really, in the long run. So everything I tell you is short-term storage for 3 months maximum. Then users have to transfer it. And fortunately, we don't have to care how they do it. So I will not talk about that one. What I want, if you're coming from a smaller institution, I think it's worth thinking about your environment a bit. So to make it really quickly here, if you have one microscope, a research group, for example. So you have one microscope, you have maybe a few microscopes, a few users. That's not really a problem to deal with. So there are commercial solutions, I don't talk about that one. And then what I say, then you have the same situation, but you have a non-standard microscope, like a cryo-electron microscope with an advanced camera system which generates between 400 and 1,500 images a second. High-resolution images, that's non-standard. But you will see how I proceed. So you may have small groups, so a small core facility, for example, and you may have standard microscope system or non-standard. But let's switch immediately down here. That's actually the situation I think we have. We have a relatively inhomogeneous and a large user group. We have multiple microscopes, so you have all the flavors, basically. It's non-organized. I think, well, personally, I don't think about file formats anymore, because I think it's basically a waste of time because you get everything from companies, so you have to live with it. That's the situation we deal with. So I think we have to go into an industry standard. We were talking a lot with Dean, but at the end of the day, an industry standard is quite cheap, is organized, and most IT guys, the one I have, hopefully, can deal with some standard things. Obviously, it's up to optimized file server system. So if you want to know more, you will not get it from me, possibly from Dean. But we have non-standard data processing requirements. So what we thought, what we should do, first of all, people were using their independent workstations. And one of the eye-opener was basically So people sitting in front here, they do nice image processing. Unfortunately, you need special workstation with graphic cards. And we realized over the past, research groups very often didn't have the appropriate hardware. So the image processing failed. And that was one of the reasons why we thought, if we manage everything, then at least we can solve all these problems. And that's what we did, something like 3 years back. Another thing, so the people will gain access to image processing software as well as their experimental data without the need, well here, without physical computer access at the facility. So this is an additional advantage. You don't have these 500 people coming to your facility. You would need a large room. We don't have a room anymore. No one needs to come. It's all virtualized. They can use their laptops, their office computers, and can access high-performance image processing tool. So, to mainly visualize the data sets. That's the other thing we realized. A few are doing high content type screening experiments, and they set up their own infrastructure. But the majority was, first of all, well, let's call it looking at the images, and then rendering images. So it's probably 80% of the time people need to do it, and they still need to do this, actually. So that's what we dealt with. So we didn't bother about high content screening where you may employ different hardware. Another advantage, it's easy to administer, can be adapted. That's what we heard basically. So you can have different flavors of virtual machines. You have an okay-ish graphic performance. It's probably not the best in its class, but it's at least better than what most people have. So most people can work. That's the aim. And obviously, a single workstation standing in some labs is used to some time, but we have a higher utilization, and obviously it's lower costs. Well, for those, we've seen images before. Basically, I guess it's similar. It's industry standards. It's coming from Dell, because we got the best prices from Dell. For those interested, I think it's a relative high performance. However, personally, I do not know. I do not hear any complaints. So I think it's pretty okay. So performance, storage is fast enough. So we can do basically everything. That's the layout. An example is here, light sheet. So basically we've seen that before. So you generate a lot of data in a short time. You have a cache server, similar to what Dean was saying. And the data is transferred automatically to the file servers, which are hosted in the central computing department. A relatively fast transfer here. And in the SLIME environment, the different virtual machines are hosted. They have all graphical computing interfaces. And communication to the external world is up here with this Netscaler, Xen-Desktop, whatever controller. This is just a communication interface, as I would call it. I hope I say everything approximately right. And that's where our user is. And that's the most important part, actually, because he doesn't need to know anything down here. He doesn't want to know, and I don't want to know it neither. So here is a very important, it's encrypted. Well, it seems to be important, but no high bandwidth requirements. You can set at home, you can set in the train, mobile connection works, so you can access your data from here, and that's what the most important thing for the user is. Because this is only the screen, basically, which is transferred, and everything else is happening in high speed. So this is a huge advantage. But otherwise, you have light sheet users or the users that sit at home here. If they want to access the data directly, they have to transfer this 1 terabyte, which is fast down here. But at one time, they should go home, and almost no one has really high-speed connection at home. So this will never happen, no problems. We never heard of any problems anymore. That's actually just the layout of a light sheet. So you have basically the operating computer, which is standing down here, operating the microscope standing here, and because it's a lot of data, the data is temporarily stored down here. Dean mentioned something very important. We stay pragmatic. We realized it's not important that the data is immediately available. Not if it's 1 terabyte. It should be available quickly. So what we implement, because there's no clue what the microscope company are doing with the data. Sometimes they access the data while it is still imaging. So we tried to move it and we had crashes. So we don't touch the data anymore. As soon as the experiment is finished, the user logs out, the data is transferred automatically. The same technology as Dean was describing is safe. At the end of the transfer process, users are informed. So it basically works quite nice. Another thing, I already mentioned it, is centralized. You can easily manage. You can generate groups. You may have users not needing high amount of data. You can generate smaller virtual workstations. So you can monitor, obviously, what Dean was mentioning. So I'm really happy he's moving in this similar direction. He's much smaller that way. Another important thing, you do not bother anymore how the user is accessed. It can be any operating system you can think of. So that's just the communication. It's really flexible. However, nothing is coming out with disadvantages. So it's, I don't know, it's something like we have something 30, 40. If you have the flow cytometry together with, it's something like 60 virtual workstations running in parallel. So theoretically, 40 users can use a software. However, we all know not everyone is using the software at the same time. So we try to use floating network licenses. That's solving most of the problem, but only almost. Let's assume Monday morning congresses are coming up, so multiple users will access one of your image processing software. So you need 16 licenses in parallel, but it's only a rush hour. It's happening a few times. That's actually a graph which we made for BitPlane. We have, I would say, we have a very nice collaboration with BitPlane and a nice, I would call it a fair usage model. We own, obviously, as everyone, licenses, and we pay maintenance for them to make things better. But we have situations where our licenses are not enough. Sometimes we need more, by chance. And we could come up with a fair usage model where we pay some additional licenses which are used, and we monitor it. It's a few hours a year. However, no problems for anyone. Everyone can start the software. Another model is with SVI for deconvolution. Initially, a Huygens Remote Manager. We don't have it. We have the Huygens Professional on each workstation. And as soon as you start it, the software is requesting a license. So in that case, SVI is monitoring the usage. And as soon as we use too many, more than what we have, we will upgrade the licenses. Obviously, things we try not to use, an example is Amira, node-locked licenses. This is really difficult to deploy. You have to make special VMs because it's running only on certain VMs. And there is also things still to be discussed. We failed fully, and I'll be open here with Arrivis. You buy one license, you want to introduce a new software in such an environment, and we all know that only a few people are using this. Initially, they test, they have to move from one software platform to the other. You simply cannot afford to have too many licenses. If you have only one and someone starts opening a lightsheet data, this lasts for 1 day, no one will use it. No one will start using it because no access. So we failed fully to have a flexible licensing model. Others people, we are in contact with GE Healthcare. So if you want to start something new, some people really are open to this. Just to show you what is the difference. Lightsheet data has been the trigger. We realize it's not lightsheet. This is a real-time acquisition of 4 channels. You see how many images are generated here. So they are just next to each other. What we realized, we have more and more high-speed imaging systems generating just normal wide field images, for example, and instead of searching manually around, we just image a whole cover slip. It's much more efficient for a user not sitting in front of a microscope. An additional advantage of these microscopes is they find the focus independently of the user. It's much more precise, and they are obviously much more rapid, generating a lot of data, which is actually very difficult to analyze and view. Another example is here. This is a confocal laser scanning microscope. And, well, you can generate a nice overview in something like 2 to 5 minutes, a whole cover slip. And then you start your acquisition. So it takes me roughly 15 minutes to generate something like between 30 to 50 3D stacks, manually selected. It's still needed. Not everything is done in high content screening. So you see this little square. So you just click in the overview on your images, you go away into your lab, do other work, and the microscope is generating data. Even if these microscopes are not very fast, they generate a lot of data over time, much more data, as we realized, in light sheet. Light sheet microscopy, you need a live organism. You place it into the microscope, it grows, it's doing something, and then you have to exchange it. So this slows it really down. Same with electron microscopy. Initially, you did single images. You don't do that anymore. We have systems really scanning the whole slide. This is actually one slot grade. This is a section. You just define tile sets, and they are imaged. And finally, you end up with lots of cells you can analyze. And that's actually what's important. I would say that's the most important thing. The IT and big data and handling of the big data should be not realized by users. We should, as microscopy should be a tool and be used for scientists, not being microscopists. Initially, I have to be fair. We got the idea for this virtual environment from Nicolas Graf at the ETH, then we implemented it. And obviously you need a good team, so you need an IT team, but we maintain it with one position. Thank you very much.